on how you can diagnose some common electrical issues with your car. So in this episode, I'll show you how you can diagnose an open circuit, which will generally cause something to not work on your car. And in the next episode, I'll show you how you can diagnose a short, which will generally cause a fuse to pop on your vehicle. And in the last episode, I'll show you how you can diagnose a parasitic draw on your battery, which will obviously drain your battery and cause a no start. Now, if you're interested in the second or the third video in this series, I'll put links to those videos when they're ready all the way at the end of this video. But I suggest you watch this video first all the way to the end. That way, those videos will make a lot more sense to you. And in order to diagnose the aforementioned electrical issues, all you'll need is a basic test light and a basic cheap multimeter that can at least measure 20 amps and some extra wiring and alligator clips, which will make your life a lot easier. And as always, if you're interested in any of the tools or products I use in my videos, like these, I'll put links to where you can get them for cheap online down below in the description box, so don't be afraid to click on them and check them out. Alrighty, so now let's start with diagnosing an open circuit. Alright, so the most common way that people find out they have an open circuit is that something on their car, like this driver's side headlight, not working. So obviously the first thing they suspect is their headlight bulb, so they go to remove their headlight, remove the bulb, then take a close look at their bulb, and then take an even closer look at their bulb, and after realizing that it's not burned out, they go, oh crap. But let's not get ahead of ourselves, and let me explain to people that don't know what exactly an open circuit is. So basically an open circuit is whenever you have an electrical circuit that is not complete. Alright, so for the sake of argument, let's say we're talking about this very basic circuit for a headlight bulb. So our circuit on the ground side starts at the battery, from there it goes to our headlight switch, and then from there to our headlight bulb. And then on the positive side, from the battery to a fuse in our fuse box, and from there to our headlight bulb again. Basically, if you have an open in any of these components that make up this circuit, then that's basically an open circuit. Whether you have a damaged wire, a switch that doesn't close, a burned out bulb, or a popped fuse, those are all open circuits. As far as how you can find out exactly where the open is, well, first thing you want to do is to grab your multimeter. Next, you want to turn it on and set your dial to continuity, which should be on the resistance scale. What we're going to do is to basically check for continuity between different segments of the circuit. So for example, from the bulb to the switch, or from the bulb to the fuse box, so on and so forth. And a continuity test is a test to see whether electricity can flow through 2 points. So if we were testing this wire with these alligator clips at the end, we would touch the 2 probes, and as you can see, we have continuity as one would expect. So here's a little mock-up of the circuit we have on the board. Here's our battery, there's our positive side, there's the wire to our fuse in the fuse box. From there we got another wire to our headlight bulb, and then here's the ground wire for our light bulb that goes to our headlight switch, and there's the ground wire that connects our switch back to the negative side of our battery. Alright, so the easiest thing that we can check on this circuit if we're checking for an open circuit is to obviously check our fuse. So go to your fuse box under the hood, look up the correct fuse for your headlights, and then you can remove the fuse for the close visual inspection. And you can of course do a continuity test to make sure. Just make sure you're not doing a continuity or a resistance test on a hot circuit. Next, what you can do since you're already here is to check for continuity from the wire that goes from your fuse to your light bulb. So as you can see, there's one wire that brings power from the battery to the fuse, and then from the fuse you got another one going to your light bulb. And here's how you can use a test light to find out which pin at the fuse box is the one for the wire that goes from the fuse to the light bulb. Alright, since the wire to one of these pins for your fuse is connected to the battery, all you have to do is to get your test light connected to ground, and then test the 2 pins where your fuse goes. And the one that gives you a light, that's the one that's coming from your battery. So there, not only we found out which pin is connected to the wire that's bringing power from the battery, but since this test light is lit, this means that we don't have an open in that wire, but also we have good wire integrity. I'll explain that a little bit later in this video. So next you would go to your light bulb and remove the connector, and then identify the right wire that's coming from your fuse box by looking at a wiring diagram, and then just do a continuity test from the fuse box to the connector. And then you would have to perform the same procedure from the connector for your light bulb to the wire that goes to your headlight switch. And then in order to make sure you have ground at the wire that's supposed to supply ground from your battery to your switch, all you have to do is to check for continuity using your multimeter from this wire to any ground. And of course, if everything checks out, you probably have a bad switch. And if you want to make sure that's your case, all you have to do is to jump these two wires. And if your headlights come on, then obviously the issue is with your switch. Now, a word of caution, when you're using a multimeter to do a continuity test between 2 points, all you're doing is to see whether a flow of electricity is possible or not. You're not really testing to see whether a correct amount of current can pass through one point to another. Because let's say you have a lot of corrosion and rust on these terminals, on these connectors that go to your headlight bulbs. Actually, if you have corrosion anywhere in the circuit, in any terminal or connector, on the positive or the ground side. Let's say you have some rust on the connector on the ground side right by your light bulb. What that does is when the circuit is closed and activated, it's going to allow for extra resistance and not allow for the correct amount of current to flow through the circuit and therefore keep your light bulb from working properly. And the way you can check to see whether there is extra resistance in the circuit is to simply load the circuit. And you can do that by simply using a test light. And the best location to do this test is at the headlight bulb. This way you can narrow down whether the issue is on the ground or the positive side. First, grab your test light and ground it, and then probe the terminal on the connector that's supposed to supply power. And if it lights up, that means that you not only have continuity from the battery to this terminal, but also current can flow through it. And next you'll switch to the other side. So you attach your test light to the positive terminal. Next, with your headlight switch turned on, probe the terminal that's supposed to supply ground. And if it lights up, again you have confirmation for both continuity and current flow. Now, to be perfectly clear, this is actually a better test than the test I showed you where we tested for continuity using a multimeter. But I feel like everybody needs to learn how to use these. That way the things we just discussed makes more sense. Now, in order to be even more accurate and to be 100% sure, you would need to use a test light that pulls the same amount of current where your headlight bulb pulls. So this one pulls about 3 amps, whereas this one pulls about 0.25 amps, or in other words, 250 milliamps. But generally speaking, if you can pull 250 milliamps, you're probably going to be able to pull 3 amps. So 99% of the time, you'll be fine using this. Now, I know what some of you might be asking. Hey, Ratchets, if you have some extra resistance here that's keeping enough current to flow through this wire, why don't you just grab your multimeter, set it to ohms, and then just measure for resistance on each segment of the circuit like we did with the continuity test? Good question. Allow me to over-explain it for you. So you can't always measure resistance of an electrical load like this light bulb unless the circuit is complete and current is flowing. Now let me demonstrate this for you on this headlight bulb. See, if we were to measure resistance between this center pin and this left pin, which I believe is for the low beam on this headlight bulb, we would get just about 0.5, 0.6 ohms. And of course, if we wanted to do a continuity test, it would show that we have continuity. Now, if that were true and this light bulb only had 0.6 ohms of resistance, then that would allow for a lot more than 3 amps of current flow from this battery all the way around. That's according to Ohm's law. Oh, and if you don't know what Ohm's law is, well, allow me to explain. Ohm's law is a law of physics that states in a closed electrical circuit, voltage equals resistance times current. I being the symbol for current in physics. So now with this equation, we can calculate how much current this light bulb with 0.6 ohms of resistance would allow to flow through this circuit. So all we would have to do is to plug in our numbers. So let's say we have a 12-volt battery with 12 where voltage goes, and then 0.6 ohms of resistance for our load, and then we would try to solve this equation for current or amps. So first we'll divide both sides of the equation by 0.6, and that would leave us with just amps on this side of the equation. And once we plug that into our calculator, we'll see that we're supposed to be able to pull 20 amps based on the voltage and the resistance in the circuit. But of course, this headlight bulb doesn't pull anywhere near 20 amps. Let me show you how you can measure that using a multimeter. First, you obviously want to turn it on. Next, you want to put your dial on 20 for measuring amps on a DC circuit. And then you want to switch your red test lead from this end to this side where you can measure up to 20 amps. So next, you want to connect the multimeter in series with our headlight bulb. So basically that means putting it between the battery source, the power side, and the headlight. So here we got the red test lead on the positive side. So current comes into our multimeter, from there out the black test lead and into our headlight bulb. And once we connect this end to the ground side of the battery, we should be able to measure the current that's flowing through the circuit. All right, so here we go. And as you can see, we got 4.8, almost 5 amps. So I believe this is actually the high beam I got here. I think the low beams get about 3 amps. But anyway, that's still way off than 20 amps that we're supposed to get if the resistance in this light bulb is only 0.6 ohms. And now that we have the current flow through this circuit, once again we can use Ohm's law to calculate the resistance in our light bulb. So once again we'll plug in 12 for our voltage, and we have 5 for current. So next we'll divide each side of the equation by 5, which leaves us with only ohms on this side and 2.4 on this side. So our headlight bulb in reality has 2.4 ohms of resistance. So there you go, folks. Laws of physics, you gotta love them. There's no arguing in them, and that's just the way things work. I wish more things was like that in real life, like arguing whether Donald Trump is a fucking imbecile or not. You can argue that till you're blue in the face, but you can't argue whether voltage equals resistance times current or not. This was the first episode of my 3-part series on diagnosing electrical issues with your car. And when the second episode is ready, I'll put a link to that, along with other videos you might find useful on this side of the screen that you can click on. There will also be links down below in the description box as well. Alright, thanks for watching. I'll see you guys next time.